gifts. So I hope I am audible. So I am Rohit Gehlot and I will be taking the week 4's tutorial for the theory of production processes course floated by NPTEL and the professor and by the Professor PK Jha sir. So in this uh, tutorial, as this is the last week for the casting tutorial, so majorly this tutorial will be devoted to the problem session of the riser design. Firstly, I will be introducing the different riser design methods, and then I will be solving some of the problems. Okay. So this session will be devoted to the riser designing. So firstly, I will be uh, briefing about the different riser design methods, and then I will be solving some of the riser design problems. So let's start the session. So there are different riser design methods. So, So for riser designing, generally there are four methods. The first one is the shrinkage volume method. Second one is the Keynes method. Third one is the modified Keynes or Newell's research method, and the last one is the modulus method. So I will be briefing each one by one very shortly. So the shrinkage volume method. So for this, generally, the I'm not discussing about all these methods in detail because they have already been discussed in the videos. I'm just briefing because we need to solve some problems on this. I'm just briefing the formulas and what are the things which will be covered. So for shrinkage volume method, generally the volume of the riser is taken as around 3% of the volume of the casting. And the solidification time of the riser should be more than the solidification time of the casting. This can also be written as now coming to the Keynes method. So here he defined a term called freezing ratio, which is denoted by the term X. Some people also write it as Both are same, just depending upon the depending upon your convenience. And the relation between these two are then coming to the side riser and the top riser. For the side riser, the area is generally written as this. And generally, the height is taken as 2 times your radius for the side riser. Now coming to the top riser. I'm skipping the basics. I'm just writing the formulas and all because everything else has already been covered. So this is taken as for the top riser. Okay. And now coming to the third one, naval research method or modified Keynes method. So here you define a term called shape vector. This is defined as the ratio of length and width divided by their thickness. Like for example, if I take an example of the cube, so all the 3 sides are equal, so its shape vector will be 2. And then a very important curve comes. I will be we will be solving a problem on that curve also at the last of this today's uh, lecture. So anything below this is defective and anything above is sound casting. Then coming to the last, modulus method.
So in this shape factor L plus W, what is L and W?
L is the length, W is its width, and then T is the thickness.
Okay, sir.
Now coming to the modulus method. So here, they use the same. They defined a term called modulus as the ratio of their volume and area, and then they propose that modulus of the riser should be at least 1.2 times of the modulus of the cast. And then there is one more term which I want to discuss, which is the casting yield. Sometimes this terminology comes in form numerical or 1 mark question. So the casting yield is generally defined as the ratio of your volume of the casting divided by volume of the casting to your volume of the gating system. And then there is one last thing. After that, we will start the numerical section. For your sprue,
So I just want to confirm that MR equal to twice MC or 1.2.
MR is equal to twice
I mean, is it 2 times MC or again?
1.2 times. 1.2 times.
Okay.
Okay, so it should be like 20 times 20% higher than your casting modulus. Okay, you can see now. So it is modulus of riser is more than modulus of casting by 20%. right?
Okay, sir.
Okay. Now the last thing is that before starting the numerical section, so the sprue for the, like, it may be asked in 1 mark question. So the generally the sprue, the ideal shape for the sprue is the parabola, but generally it is because of the because of the design constraints, it is designed as a tapered. So there is similarly there is for runner also. So you can also see that. So now let's start with the first problem. I will be I will be solving the first problem so that you all get the basic idea, and then after that we will be moving ahead. So firstly, the let's start.
So the ideal shape is parabola and the other one is tapered or trapezium. Tapered. Okay.
Yeah, yeah. So let's start. So the first question is we need to design a dimension of a cylindrical riser. Okay, so a cylindric we need to design a cylindrical riser which will be used for a casting brass cube which has dimension of 20 centimeter, and also the volume shrinkage is given to us is 9%. So let's start. So firstly, we need to read the question carefully. So if in question it is given a side riser or a top riser, sometimes it is not mentioned, sometimes it is. So here it is mentioned that it is a side riser. Okay. So for side riser, we usually take h is equal to d. I am not discussing the theory part why it is so. We are just here for solving the problem. So that's why. So side riser, the height is generally taken as its diameter. Now this problem can be divided into 3 steps. So firstly, like the we come to the step one. So in the step one, like we will be calculating like what will be the volume of the riser. So we will be solving it the shrinkage volume method. So as we already discussed that I will come to that volume of the riser is taken as 3 times of the volume of the casting, right? So volume of the riser is 3 times volume of the casting, and then the volume of the casting is as there is a volume shrinkage of 9%, so it can be like written as 9 by 100. Then your volume of the casting will be 20 cube 20 to the power 3 because it is a cube. So now here from here, if you will you can like now as your h is equal to d, then you can equate it to pi r square h, then you can, or pi by 4 d square h, then you can equate h is equal to d, and then you will find r something. So you got the r values. Now the step 2 part. So now you can write v by a of the riser. When your h is equal to d, it is directly equal to d by 6. You can calculate it. I will verify this in the next problem. So just to move things quickly, because I need to have like so many. We need to solve so many problems today. So that's why just for the sake of timing. So V by A of your riser is equal to D by 6. When you will calculate this, like let's calculate the what will the R value will be coming. So it will be coming as 7 centimeter. Then when you will calculate your V by A ratio, it will be coming around 2.33.
So for while calculating the V by A, it is actually the volume of cylinder by surface area of the
Yeah. Now
cylinder.
in the area you need to include both your peripheral area, pi d inch plus as it is a side riser. So I have written here for your side riser the area is this 2 times pi by 4 d square plus pi d inch. Okay. And for your top riser the area is pi by 4 d square, because we are not like this is your riser. In the top riser we are taking only this one area. Okay. But in case of your side riser, both the area comes into picture. So that's why this area both are taken into consideration as well as the peripheral area. Okay.
Can you once again say? I didn't understand.
Okay.
For the side racer, we will be taking. Do we neglect the top portion of the?
Yeah. So suppose this is your side riser. This is your riser. Okay. So for the top riser, as it will be uh, installed like this way, right?
Yes, sir.
So this area won't be like useful in any of the heat transfer, right? So only these three surfaces
Yes.
will be uh, in helpful for your top riser. While in case of your side riser, as it is installed in your sideways, so both the bottom areas as well as your peripheral area is useful. That's why two times of your this area and plus this area. Okay.
Okay, sir.
Okay. So if we will calculate by that area, that formula for side riser, we will get the V by A as D by 6. Okay, so let's as our V by A is okay. Now let's calculate V by A for our casting. So generally in every problem we need to calculate V by A for our casting, V by A for our riser. Then then we always equate our V by A of the riser should be greater than V by A of the casting. Let's do it. So V by A of casting, if when we calculate this, so here our V by A of the riser is 2.33, while our V by A of the casting is coming as 3.33, right? Which shouldn't be the case. That means it is showing. I will write it. V by A of the riser is 2.33, but we don't want this because if that will be the case, our riser will be solidifying first, then our casting will be solidifying. This would be the reverse. If that would be the reverse of the case, then our answer was right. We would have been said that our that the radius of the cylindrical riser which need to be designed is 7 centimeter, which is right. But here for that our V by A of the casting is coming as 3.33, while for riser is coming as 2.33. So then if that comes, we need to check this for each and every problem. If that so then what we will do, we will set the condition that our V by A of the riser should be more than over V by A of the casting, right? That means our riser should solidify at the last, and then V by A we can write it as D by 6 or R by 3. It should be greater than 3.33. So that gives like R should be greater than or at least equal to 9.99. So I'll write it as 9. So our radius should be at least 10 centimeter. Then only our riser will solidify at the last, and then so this is how we design our. So whenever a problem comes to design something like a side riser, we need to give it two dimension. Like first one is the it's. Suppose we need to design a riser, so we always be there should be this dia and this height. So we need to give or find these two parameters, this diameter and this height. Generally they are half or they are equal, so if they are side or top riser. So but the main the thing which I wanted to cover in this tutorial was, firstly we always should remember that our V by A of the riser should be greater than or equal to V by A of the casting. So this is the major learning uh, from this problem, that our V by A of the right. Yeah.
Actually, I understand till that we found out the V way of casting is more than V way of riser. Then I can explain what we did after that.
Okay, so you got it till this step, na, right? V by A
Yes,
of the
sir.
riser. Okay.
We got the V by of riser is greater than V by of casting,
Yeah.
which we need like that, but we are not getting the value is reversed. So then what did we do after that? I mean,
Okay. So
after
like
we
okay. Okay. Yeah. So this V by A of the riser. So as it is a cylindrical riser, right?
yes, sir.
As it is written that it is cylindrical and also it is a side riser. Okay.
Yes.
So for the cylindrical and side riser and whose h is equal to d. Okay. So when you will put these things in this formula for h is equal to d.
Okay.
Okay. Then your v by a ratio will come as d by 6 always. Like I'm not saying to remember this, but with practice you will remember this
Okay, sir.
because okay, because in the all the problem it is like the same. In second, third, and fourth problem I will solve this. I just wanted to like end this problem quickly, so that's why. So
For the cylinder, the V by A will be D by 6
for
uh,
side riser
for side raise.
and whose h is equal to d for that you can calculate it also like
That
directly
will
put.
be the diameter. Okay.
Okay.
Okay, sir.
So, and also there are the learning one is that for V by A of the riser should be greater than V by A of the casting. And second learning is that in some of the problems, it is not written that whether it is a side riser or top riser. So you can choose accordingly. So if it is a comprehensive problem, there won't be any problem. And if sometimes, but in the numerical problem, it is usually mentioned. Like if you are assuming it as a side, that if you have to assume it as a side riser or top riser.
So if
Okay.
it is not given, we can assume anything. Anyone.
Any of the thing, yeah.
Okay.
Then you can solve it by assuming that h is equal to d, h is equal to d by 2, any of the things. Okay. So I
So we
hope,
can
yeah,
in this slide, then actually the D by 6 is actually written as D by. Can you show the next slide? That D by 6 is actually R by 3.
yeah. I directly calculated d can be taken as 2 times r, no?
Okay, so then
Okay.
we find out the radius, which is corresponding to the 3.3 value of the casting.
Yeah, you can directly calculate r also. Okay, dia also. You can write it as d by 6. So you will find your d should be greater than 6 times of this. I just found it in terms of r and h. No, that's not an issue. Okay. So let's move to the next problem. So this problem is regarding the shape factor.
So one more
Yeah,
thing is, will the riser be in always in cylindrical shape, or will we will be using any other shapes?
it can be used in n number of shapes depending upon the problem. But generally, in
We
your
will be using
case,
cylinder.
any type of riser you can use. Like depending on some people also use trapezoidal, some people all use a taper, some people use cubical. N number of type of the riser can be used. But generally, because of the simple to make the problem simple, generally it is written as to use the cylindrical or side riser. Okay.
So we are having that H equal to D and V by equal to D by 6 only for the cylindrical riser and top riser, side
Then
riser.
for cube also it is a by 6. You can directly see that volume is a cube and the area is 6 times a square. So it will be a by 6. Similarly for uh, you can calculate like you can make a table. There is a table also available in I think European RAW where for different like shapes he has written what are the V by A values. But you don't need to mug up these things. Just with time you more the problem you will solve, the it will become easy.
So we
Okay.
can use this for cube and cylinder.
You can use V by A formula for D by 6. It can for cube and cylinder, right? But the formula, the main thing which you need to remember or taking into your heart is V by A. Okay.
Okay, okay, sir.
And this V by A of a riser should be greater than V by A of the casting. This thing, if you forgot, then the problem will be, we won't be able to solve the problem. Okay, then let's move to the next problem because we also need to wrap this in. So the second thing is that the shape we need. The problem is that the shape factor of a casting in the form of an annular cylinder of outside diameter 30, inside diameter 20, and the height is itna will be. So we can. So the annular cylinder. Annular cylinder means. So there is a cylinder inside which there is also a cylinder. Okay, and then the outside diameter is 30 centimeter, and this inside diameter is 20 centimeter, and its height is 30 centimeter. We also need to take this correction factor also into picture. So because in formulas the correction factor also comes. So for solving this, we know that the shape factor is the ratio over L plus W by T for this, and then thickness we can calculate directly by the difference between these two things, 30 minus 20 divided by 2, which will be coming around 5 centimeter. The major thing is that how we will calculate the width of the cylinder. So that is the beauty of this problem. So you can see like there is a mathematical derivation also for that. You can go through that. So generally the width is written as pi times d mean. So why it is taken this, you can search or search in net for derivation of this. But generally it is taken as pi times d mean, or you can understand this by your basic imagination. So pi times the d mean will be your 30 times 30 plus 20 by 2. So by calculating, it will be coming as around 25 pi. Then you can directly calculate the shape factor. The shape factor will be the length is generally taken as the larger. Like if suppose it is 30, it is also 30. So generally the larger one will be taken as the length. It is both the uh, length and both the dia and height are same. So generally it is the larger one. So 30 plus the width is 25 9 pi divided by your thickness. So you can solve it. Then you will get the shape factor. Okay.
So
So
I'm
yeah.
having a table with the geometry and shape factors for cube, sphere, and cylinder. Shape factor taken as 2. Sir, is there any table like that?
Sorry, can you repeat?
Sir, in my notes, I am having a table of different geometries and shape factor as Q for cube, sphere, and cylinder. The shape factor is taken as 2, 2. Is there any are will be using such kind of value? I mean,
So you have cube, na?
yes,
So cube you just directly all the three sides are same, right?
yes, sir.
So you can write it as L plus W by T. All the three sides are same. So the ratio will be coming as 2, right?
Okay, sir. Oh, like that.
Similarly for the sphere, all the everything is about R, like, right?
Yes, sir.
So again L plus W, everything is R R R. So again it is 2, right?
Yes, sir.
So for the cylinder again, anything specific you have written?
The cylinder is also taken as 2.
Okay, so cylinder like if it is, I think it should be R is equal to H or some relation. Then only you can write it as 2. There should be something. Okay,
Height is taken as diameter.
yeah. Then only because everything will be same. L plus D by D. Then it will be 2. Okay.
Okay, sir.
Okay. So then let's move to the next problem. So there is a cast steel slab whose dimensions are 30 times 20, 30, 25. It is poured horizontally using a side riser. So firstly, what we should remember to see which type of riser it is. Then clearly it is written as there it is a side riser. Okay.
Sir, but we didn't say anything about why we calculated that shape factor. I mean,
Mm.
after calculating the shape factor, What is the use of?
Uh, I'm just moving step by step. So like you get
Okay,
all the, because we need to cover all these four methods now.
okay, sir.
Sometimes in your exam directly safe factor will be asked. Sometime in your exam, the utilization of safe factor will become, because like safe factor can be asked in your 1 mark question, like and its application can be asked in your 2 marks question, right?
Okay, sir.
So now let's move to the problem 3. So there is a cast slab whose dimension are 30 times 40, 20 times 5. It is poured horizontally using a side riser. So firstly it is a side riser, and the riser is cylindrical in shape, okay, with diameter and height both equal to d. So diameter then the freezing ratio of the mold is. So we need to calculate the freezing ratio, so which we discussed previously. So your freezing ratio is this, the ratio of this or this, anything you which you want to take. So you need to calculate this. So now calculate this, because sometimes in exam the things will be asked from the terminology. Calculate the freezing ratio, calculate the modulus, calculate this shape factor. So we should remember these terminology. What is a shape factor? Sorry, what is what we call as a shape factor? What we call as your freezing ratio? What we call as your different things. So this should be in your mind. So let's solve this. So for d is equal to h, so let's calculate the volume. So I will be giving you the last problem to solve today. This problem you will solve, uh, this problem or fifth problem you will solve, till fourth I will be solving, because just to let you know like how things are being solved. So the third problem is this. So firstly we will calculate the volume of the slab, which is like 30 times 20 times 5. Then as we need to calculate the freezing ratio, so firstly I will be calculate the modulus of the casting. The modulus of the casting is V by A, and when okay, V by A, which can be written as your volume is this, so 30 times 20 times 5, now divided by your area. So area, as it is a cuboid, so area will be 2 times LB plus BH plus HL, okay. So, so 2 times in bracket it will be like 20 times 30 plus 30 times 5 plus 20 times 5. Then it will be calculated. It will be coming around 30 by 70. It will come as 1.76. Okay. So we calculated the modulus of the casting. Now the second step is, this is the first step. Then step one, I can write it as step one. Then step two, we will calculate the modulus of the riser, which is equal to V by A. Then I will again as okay. Now let's solve why it came. So I will be writing as our modulus of the riser as V by A. So our volume will be pi by 4 d square h, then divided by 2 times pi by 4 d square plus pi dh. Then h is equal to d is given. So this can be written as pi by 4 times d cube divided by it will be pi by 2 times d square plus pi d square. Right, so it will become as I'm cancelling the pi by pi from all the, and also d square. It will become d by 4 times 1 by 2 plus 1, So then it can be written as d by 4 by 3 by 2. So it will come as d by 6. So now if we calculate the freezing ratio,
So for cylinder, we can use directly d by 6 without doing v by a.
sometimes you just need to see like whether it as it is a side riser, right? So side riser, you know that your area will be 2 times pi by 4 d square, and also your h is equal to d. If this is the case that if your side riser and h is equal to d, you can directly use d by 6 formula because else you will have to again calculate this in your exam and this, so that may.
So actually,
Yeah.
the h equal to d is the assumption that we have taken, or will the questionnaire give it?
So here it is given in the problem
Okay, so
with a diameter and height both equal. Okay.
okay, so if the height is not equal to diameter, then we need to calculate that v by a.
Yeah, then we can't assume that h is equal to d. Okay. If in problem generally it is given as there will be some relation will be given. Sometimes it is given as h is equal to d by 3, h equal to d by 6, something something. If h is won't be d or d by 2, you can like with practice you will remember h for the modulus of the riser for h d h for h is equal to d and h is equal to d by 2. But sometimes if other relation is given like d by 3, d by 6, then you can some after a time you will directly imagine like in your mind like this is okay pi by 4 d cube. So if I will put d by 3 here, like how the things will become. So that's not an issue. Main thing is understanding the funda. Yes. Okay. So let's do. So for the freezing ratio is modulus of the riser divided by modulus of the casting. So your modulus of the riser is d by 6, and then the modulus of the casting is 1.76 or 30 by 70. So you can directly put it this way. So this will come this modulus of the riser. As diameter is not given, like what is the diameter value, so we will have to leave this here only till here. 17 d by 180 is your freezing ratio. Okay. If in your problem the value of the diameter would have been given, then you you would have been you would calculate the what is the value of the freezing ratio. So if you have any doubt, let's discuss, or else let's move quickly to the next problem. Okay.
So I have a doubt that actually we are using the modulus method. Then why we are taking this freezing ratio? Uh, the freezing ratio method is actually Keynes method, isn't it?
Okay. So the you can see that what the people the ratio. If you see this, the freezing ratio is the ratio of the two modulus only. This is your modulus of the riser. This is your modulus of the casting, right?
Yes, sir. Yes, sir.
So yeah. So let's
So that's
yeah.
why.
Yeah. So here is your modulus. So that's why I just put it that way. Okay.
Okay, sir.
Okay. Yes. So this is the problem. So try solving this problem. This is the same as before. So I will read it for you. So for producing a casting whose dimensions are given, and the second important thing is it is a side cylindrical riser. Okay. Now we need to determine the diameter of the riser. Assuming that the modulus of the riser is 20% higher than the modulus of the casting. Okay. So try solving this. Then we will discuss this. This is simple problem, not a big thing, but just you uh, if you'll do let's do proper practice.
So this one will be done using the first method, isn't it? Volume.
So as it is given that 20% higher than this. Okay. So it is given. So generally I just discussed like for 20% higher we we do this by modulus of the riser. is equal to 1.2 times modulus of the casting, right? So you just need to calculate modulus of the riser in terms of dia. As it is side riser, it will be d by 6. So directly the modulus of the riser is VR by AR, which will be d by 6. So you need to equate d by 6. Here it is given that modulus of the riser is 1.2 times modulus of the casting. So directly you write this modulus of the riser is 1.2 times modulus of the casting, and then put modulus of the riser is d by 6 and modulus of the casting VC by AC. So just and then from this you can calculate the volume and area. Just find the dia values. Okay. So try solving this and tell me like what the diameter value will be.
So here can we use that d by 6? Actually we cannot use that d by 6, isn't it? For the riser.
Right?
For the riser we can't use d by 6 directly here since the height is not.
Yeah, here height is not given equal to d, but we will have to assume that uh, you can assume h is equal to d, h is equal to d by 2 as per your convenience because it is not given. But
Okay.
without that, it will be coming. It will be won't be coming na. If we so generally it is assumed h is equal to d. Okay.
Sir, I am getting diameter as 21.6.
21.6. Can you tell me the unit?
It's in mm.
21.6 mm. I think you did the unit mistake. Try again. Like see where you have did.
Okay, sir. So when I am doing it in the meters, I am getting 0.216 meter.
0.216 meter.
Yes.
Yeah, right. It is the right answer. So just for the others, like I will solve this. So the modulus of the riser is 1.2 times modulus of the casting. So as it is given in here. So so I will write it as modulus of the riser can be written as volume of the riser times the area of the riser. Now this can be written as your again pi by 4 times d square h times 2 times pi by 4 d square plus pi dh. So by solving you will get d by 6. In our previous problem also we will solve this for h is equal to d time. Okay, then I can write this as d by 6 is equal to 1.2 times the modulus of the casting, which is your volume of the casting time area of the casting, which further can be written as 1.2 times the volume of the casting is 300 times 300. The time again your area is the cube, so 2 times LB plus BH plus HF. So when you will solve this, you will get dia as 216 mm. Okay. So let's move to the next problem. So the problem is like this. So for a sand casting, a steel rectangular plate with a dimension of this and a cylindrical riser. Again, it is cylindrical riser which we need to design. The height of the riser is, so the height of your riser is equal to its diameter. And then the total solidification time for the casting is 2 minutes. Is 2 minutes. And then in Chernow's law, I think it has been already been discussed by Professor Jha, and there is one, he has solved many problems in one of the lecture also. I think you all went through that, so this is related to that video only. So the solidification time of the casting is 2 minutes. Now in the Chernow's law, for estimating total solidification time, the exponent is 2. Now for the solidification time of for TS solidification time of 3 minutes, the diameter of the riser we need to calculate. So try solving this, then we will discuss this problem. So if you don't recall the formula, or like then I will write it as T solidification was written as K times your V by E to the square. So try solving this now, and then we'll discuss. Okay, so like taking so many times, so let's solve this. So firstly, like uh, these are the given thing. Your volume of the casting is 80 times 120 times this is 20, 20 mm, and H is equal to D, and your solidification time for the casting is 2 minutes, for which K is equal to 2. Now for T solidification of 3 minutes, dia of the riser we need to find. So from here, like we can write it as T solidification of the riser is K times your square of the V times A. It is given as 2, and this is also so what I did. So this is not the K. One second, let me check. So the exponent to be taken as 2. Okay. So this is N, not K. So this is this. This here. This is your exponent, right? Okay. So here also I will write it as N is equal to 2. So K times V by A. So again the volume will be you will write it as 80 times 120 times 20. Now divided by 2 times 80 into 120 plus 120 into 20 plus 20 into 80 to the square. The exponent is 2. From here you will find out the value of K, right? Now the K value will be coming around 0.04013. Now you will use this value to calculate the when your solidification time is 3. So you will write it as T solidification is K times V by A square. So this will be your 3 times your D value is 0.0518.
Yes.
The unit, can you tell me the unit?
Meter.
Yeah, right. The K will be your 0.0 this, and then your V by A to the square. So from here you will be getting your V by A as 8.64, and then you will take it as V by A or D by 6 as we are doing again and again. So from here you will get your D value as rightly said around 51.8 mm. Okay, so now let's move to the last topic of the today. So firstly we will discussing about the NRL or the safe factor method. So there are like I don't know whether it is in syllabus or not. We will do one problem and then we will wrap the casting session to it. So firstly, like in your NRL or the safe factor method, though, so if there are appendages are provided, so there may be 4 types of appendages. I think it has been covered. The first one is the bar feeding plate.
Is this kind of question can be done in 1 minute without calculator?
Can you repeat, please?
I mean, we have done a question just before this, isn't it? Is it good to calculate.
Oh, without. Okay.
Most of the exams they are actually not giving the calculator, and it will be 1 minute 1 mark questions in it.
Yeah. So like for that, if you have options or like ABCD are given, then you can do hit and trial also, like by directly putting your formulas. Some of the problems I will add from next time those MCQs also, where you can directly use your MCQs values to solve the problem. But generally, if you the basics should be clear now. Starting, we shouldn't be looking for the shortcuts. So firstly, we should go step by step, like what is the procedure, like how it is done. You can directly with practice, if you get, you can directly, there was no need for calculating key values. You can directly like write T solidification of the riser 1 for 2 minutes divided by T solidification of the riser for the 3 minutes is equal to V by A of the riser divided by V by A of that. So directly would have volume would have also been cancelled. So only like for the volume here it won't be cancelled, but you didn't have to calculate the key value. So one step was skipped. So then there will be, or on the left side there would be a ratio of 2 by 3, and then on the left side for one you directly have to calculate the V by E ratio, and then the other V by E would have been calculated. So one step would have been reduced, but for starting it is good to go step by step. So on the latest stages we will see. So now coming to the appendages types. So there are four appendages. So firstly we need to see what are the appendages or these things. So firstly there are like two things will be coming. There one thing is called plate and another thing is called bar. So the plate which has the, so I'm talking about, suppose there is a casting, this type of casting is given, and then suppose there is some attachment is added like this way. So you need to, firstly you need to identify which one is your plate and which one is your appendages. So like suppose if you have some provision like this and another some provision like this, so then how will you
Actually, the what do you mean by feeder? I mean, is it the pouring basin or
no, there is we are not talking about the pouring basin and all. So firstly I am talking about that, suppose this your casting which needs to be filled. So, but there are like two uh, like your entrance is this way from the pouring basin and all, like this is being filled with your molten melt. So firstly this is your bar, because of its thickness and length width is lesser than uh, 3 to 4 times of its thickness. So this is from, then if that is the case then it will be called as bar feeding plate. Like, but if it is another case, like the filling is done from the opposite side, then it will be your plate feeding your bar. Now both are the around same length and dia, then like suppose this, then it will be your plate feeding plate, and then similarly bar feeding bar. I'm telling about these things because some, I don't know if it is in syllabus or not, but still. So then there is a called NRL method. So in NRL method, we do use these kind of things. So firstly, we need to find what type of appendages are these. Then we use this graph. Firstly, we here it is. Firstly, we will read this graph. So here it is written that it is a graph between your percentage of parasite volume. So another thing is what is called a parasite. So this thing, because there is a movie on parasite also. So similarly like this, so on the surface of this casting there is a parasite or some another provision is there. So that is why it's called parasite. So because it is taking the molten melt away from that, away from that, and then it is getting filled. It is not filled directly, it is getting filled from that your plate or bar. So it is called as parasite. So this is a plot between percentage of your parasite volume to the thickness of your parasite by thickness of the parent. So the
so?
parent one,
Actually, this feeder plate means it's just before the casting there will be another plate.
yeah, right, yeah,
So
right.
the gate will be connected to the this plate.
Gate will be connected to all, gate can be connected to one thing, na? either to your parent or to your parasite, right? Either to your bar or to your plate, either to your like n number of intrusion can be on your casting, n number of provisions can be on your casting. So suppose this one is getting filled, and on the latest stage this will be filled after it get completely filled, or simultaneously it is getting filled, the other thing will be filled, right? Can you imagine?
Okay, sir. So the this just before the plastic moldy cavity being filled.
You just imagine your mold cavity is not rectangular or cubical. Just it is a cube, but some on its left side or on a right side or on a top side, there is another cube is placed on that, which is a comparatively smaller size. Okay,
Okay,
so similarly like that. Uh, so just focus on this plot. So this is plot. So let's move to the problem. Then only it will be understood. So this is a problem. So we need to calculate the volume of the riser. So this is your plate and this is your bar. So these two things are to be filled, and then we need to calculate the what will be the riser which we will have to use for filling these two things, this plate and the bar. Firstly, it is your parasite, and this is your parent, which is getting parasite is getting filled from this plate. Okay. So firstly, what I will do uh, for solving these type of problems, firstly we divide it into two parts, as I already divided first and second. So the second part, which is the bar, we won't consider its volume at the starting. Firstly we will consider the volume of your plate. So volume of the plate can be written as 12.5 times 12 no 2. Okay, 12.5, but before that okay. So the firstly we will have to find out the ratio of the thicknesses. So one have the thickness of 5, another has the thickness of 2.5. So 2.5 by 5 is equal to 1 by 2. Okay, and then if we calculate the volume of both the things, volume of the bar is can be written as 10 times, it is 2.5 times 2.5. This is 2.5. So the volume will be coming as around around like 2.
So actually, is this the application of that shape factor that you have mentioned earlier? Okay, so the another thing is actually this casting and first the parasite will be filled and then the casting filled, or is it the reverse? Yes, sir. So, but what is the actual necessity of that parasite? Yes, sir. So actually, in the last session, I actually said about the application of that shell molding, and I got that PDF. So can you explain that using? Uh, yes, sir. Or should I present it, or can you give me your mail? Okay, sir. Okay, sir. So you can put your mail in the chat box. I will mail it. Do you have that PDF of Campbell that you have mentioned earlier? Actually, I searched for the book, but I didn't get that. Oh, okay, sir. Okay, sir. Sir, actually, I am mailing it, and I will also present it. Okay, sir. Uh, you mean the next week? So I think it's actually forging or